Hey guys, welcome back. Just got a little review problem for you for this homework set. So on the first one, just a classic, got a cannon shooting something from a trench underneath the ground. It's 8 meters below the ground, but it's going to be very similar to when we shot something from a cliff. The only difference is now the delta x is just positive, but it's really kind of the same process. We're shooting it from a cliff at an angle, and we want to know the range on it, how far it goes. Now, I know it's been a while, but I wanted to connect you guys back to the 3 steps of problem solving, which are very simply writing down what do you know, what do you need to know, and what equations can connect you from what you know to what you need to know, because that's really what problem solving is all about. The first step is just throwing down the information that you actually know. So I'm going to do that in this chart here that I made. All right, so I've set the problem up, writing down everything that we were told in the problem. Everything that has to do with the vertical y direction is in green. Everything that has to do with the horizontal x direction is in purple. And the stuff that we're digging for is in white, which is the amount of time it's in the air and how far it goes to the right. As always, in a projectile problem, time is the key. You start in one direction and you work toward the other. And also, since the main question we're looking for is delta x, we know that's going to be step 2 in the problem. So that's why I knew at the beginning to set it up ytx instead of xty. It depends which side you're looking on. You'll always start on the left and work your way to the right. All right, so we're looking for t, and we have all this information, so we know we're going to move from the y direction to t. And this is the equation that does it. Most of the time, if you've got a problem where you're trying to figure out how much time it's in the air, this is your guide. Delta y equals 1/2 at squared plus vit. Know it, love it. It's very important. And then we just toss this stuff in. I left the t's in white to show this is the thing we're digging for. All the other values we already knew. And then use the quadratic formula or just toss it in your calculator. We've already done the quadratic formula, so I don't really want to go over it in the video. But when you do it, you get 2 values of t, 0.3 seconds and 0.54 seconds-ish. So the important thing is, the reason that you got 2 answers is because at one moment, it is 8 meters higher than you started because it's here. And at another moment, it's 8 meters higher than you started because it's there. So it should be very obvious to you that you'll want to pick this for your value of hang time and not the 0.3, because that's not what we were looking for. We didn't want to know how far it was to the right here. We wanted to know how far it was to the right there. So now that we know the amount of time it's in the air, it's actually very simple. All we have to do is multiply it by how fast it was going to the right. And if it was going 10 meters to the right every second, and it was in the air for 5.5 of those seconds, then it makes sense that it went 56 meters. Don't forget to slap units on your final answer, since we skipped units for all this stuff. So on this one, it says a 50-kilogram plank that's 5 meters long hangs 2 meters off the edge of a ship. If the guy is 60 kilograms, how far off the boat can he go before the plank rotates clockwise? And torque and center of mass are your friends on this one. By the way, we're ignoring the mass of the pirate guy back here who's pushing him off. Just pretend he's not really on the plank. So basically, this thing balances just fine at this location because it's being, kind of rotated down on this side more than it's being rotated down on that side. So it just kind of sits there. But as the guy walks out, it tilts more and more and more. So let's jump into this one. So first of all, a quick refresher. This is a torque problem because it's talking about rotations. And a torque is a force away from the balance point of something that can cause it to rotate. I say that it can cause things to rotate because it only causes a rotation if the torque is out of balance. If the torque is balanced both ways, then the object will not rotate. And it's equal to force times distance away from the point of balance. So writing this out, the net torque is equal to all the torques that are causing it to try to rotate this way, clockwise, minus all the torques trying to rotate it counterclockwise. Or another way to write it is to just say that those 2 torques are equal. So I worked out the whole problem for you, but the really big trick you had to use was center of mass. So if you look at the plank over here, if the whole thing is 50, then this chunk is 30 because it's 3/5 of it. So that's a 30-kilogram mass over here. And it's on average 1.5 meters away. So that's why I wrote it this way over here. Likewise, this one is on average 1 meter away. And we add in the extra torque from the guy, which is 60 times 10 times d, and solve.